Hello, geometry class. So now we've been in school for a couple days and we're able to finally start getting into actual content. So we're going to jump right in. We are in section 1-2. We are skipping section 1-1 because it just doesn't really cover everything that we really need. And we are going to be talking about identifying points, lines, and planes in this chapter, in this section. I would like for you to be able to identify them, name them, and kind of determine where they are and how they relate to one another by the end of this lesson. It's going to be a lot of vocabulary. So let's go ahead and jump right in. First of all, what is a point? A point is something that indicates a location. There are two things that you should know about this. It does not have a size. Oh, sorry, one thing. It does not have a size. I was thinking about something else. So an example of that might be A or R, stuff like that. Down here in this image, let me kind of make those a little bit darker. This would be point D or point B, and so on and so forth. Then we have something called a line. It is a straight path that extends forever in two directions. Now, the way that we would name that, we need 2 points. So if we were to name this line right here, we can say line AB, and that would be fine. We just need 2 points that fall on the same line. Now notice the symbol that I put on top of it. I have a line with an arrow on both ends. So hopefully that's connecting for you. Since a line goes in 2 directions, like both directions for forever, the symbol is going to have arrows on both ends. You are also able to name the same line by flipping the letters around. So in this example, line AB, which is this one, is the same thing as line BA, which is this one once again. You could also call this line right here line AC. And so on and so forth. There's quite a few different ways that you can do that. Now, if two things are collinear points, then they are points on the same line. So hopefully the word itself was kind of a hint for you. Think like the word co-worker. You are both working at the same place, so collinear. They are both on the same line, and line is in that word L-I-N-E right there. So points on the same line. Examples of that would be A and B, or B and C, or A and B and C. Non-collinear points, you guessed it, 2 points not on the same line. Okay. So for an example, in this image, that could be point B and point D. For an example of non-collinear. We cannot say C and D because C marks the intersection of these two lines, so C is just falling on both of them at the same time. So C is collinear with A and B and D, since it's right in the middle. Okay, now we're moving on to something called a segment. Like I said, a lot of vocabulary. A segment is very similar to a line. The only difference is that it's like a line cut a little bit, where It does not extend forever anymore. So it is a section of a line that has two endpoints. Okay. So line segments fall on lines themselves. I'm gonna make this a little darker because it's kind of hard to see. There's arrows, and then we have point A, B, and C. When we are denoting this in symbols, if we want to say segment AB, well, it's similar to the line symbol, but now we just leave it plain. We don't put arrows on the ends. So segment AB. Or we could have segment AC. Or we could have segment CB. We have lots of different options here. That means like AB, it's just from A to B. That's the only part that we're considering. If I were to put arrows on the ends of it, then that would mean the whole thing extending for forever in both directions. A ray is kind of in the middle between a segment and a line. A ray is, once again, it's only part of a line. And it has one end and extends forever in excuse me excuse me, in one direction. Not the band. So the symbol for this, let's say I wanted something that started at point A and extended to the right on this example. I could use B or C, it doesn't matter. So I'm gonna have AB, and then I'm going to put a ray symbol above that. Notice because it's a ray, it has one endpoint and extends forever in one direction. It's missing an arrow on one side, but it does have an arrow on the other. Something that's important though is that order matters here. So ray AB is starting at A and going to the right on this line. If I were to say ray BA, then I'm starting at B and going left. So the order matters here. That's pretty important. With the line segment and the line itself, because the endpoints are the same, meaning like either they extend forever or they have endings, it doesn't matter as much. But for a ray, the order is very important. You can have opposite rays, and basically that's just two rays with a matching endpoint. Thus forming, I'll do it like this, forming a line. So, right here on this example once again, if I were to say ray BC and ray BA, well, those would be opposite rays, and because they have B in common, this connects the two and it forms a line. So I'll go ahead and write that out. Ray BA and ray BC. All right. The next word that I want to talk about is something called a plane. A plane is a flat surface that extends forever and it has no thickness. Okay. The most similar, or the most simple or common example I can give you for this is like a piece of paper. This piece of paper, yes, it does have a little bit of thickness to it, but ideally a plane would have no thickness, but this piece of paper extends in 2 dimensions, and if it were bigger, it could end up going on for forever. So that's the concept of a plane. Now, a plane can either be named by 3 points that are on it, or sometimes they'll write it in a different font, maybe like, I don't know, like this. They might make the font kind of curly, and then you can call it plain X or something like that. So either you need to have a letter denoting it, or you're going to use 3 points to name it. Coplanar points, so co, remember, meaning together or with one another. Planar, so they are going to be points in the same plane. So an example of that could be M and O. Non-coplanar points, and you can't really see this, so I'm going to make it a little darker. There we go. Non-coplanar points would be points, once again, not in the same plane. So an example of that, T is way up here above this plane. And so maybe T and N would be a good example of that. So T and N are not coplanar points. All right, so this was all very definition heavy. We're going to start applying this a little bit, just with naming them and making sure that we're familiar with the symbols. Okay, so for example 1, it says, use the figure to the right. First, we're going to name 3 coplanar points. So you can have plenty of answers for this, okay? We have a plane that's going up and down, plane N, and we have a plane going kind of left and right, plane T. So it doesn't matter which plane you pick, you just need to make sure that there are 3 coplanar points. I'm going to choose the one going left and right, which will be plane T, and I can see that point B, C, D, and E all fall in that plane. Meaning if there were a piece of paper representing this plane, these dots would be drawn on it, basically. So I'm going to say points B, C, D, and E. I did 4, it said 3, whatever. Then it says name a line. Okay, well, we have a lot of options for this once again, meaning we can call the same line more than one thing. So if we were to name this line right here, we could call it line AC. Remember, when you are labeling a line, you need arrows on both parts of it. So I'm going to call that line AC. And then I'm going to put or in here because another answer could have been line CD. Or one more answer, just so we get some practice with it, could be DB. But notice, because it was a line, I put the arrows on both ends of that symbol above my letters. Then it says, name the horizontal plane 2 different ways. Okay, so our first way of naming this plane is by the T right here that's kind of in a different font. Like this one's more curly and kind of cursive compared to the other letters. So we can call it plain T. And I'll try to make my T a little fancy for you. Or remember, we can name a plane by points within it. So we can also call it plane, and then we need 3 points, not just 2 or not just 1, we need 3. Because if we were to say C, well, that could be falling in both of them. D could fall in both of them as well. So I'll choose B, C, and E. All right. Now it says name 4 non-coplanar points. All right. I meant to get rid of this because A, C, and D are all coplanar on both ways. So we're going to get rid of the 4 there, and we're just going to name a couple of non-coplanar points. E is coplanar with everything except for A. So I am going to say points E and A. Notice how E is on the plane that is horizontal, this one right here. A is only on the point or on the plane of this one going up and down. I couldn't say B, C, or D because they fall on the intersection of these planes. All right, for problem E, it says name a line in plane in. Okay, plane in is this one going up and down. So there are options that we have here. I'll do the one that's probably most obvious to you, which is this one going up and down. So I'm going to call that line CA. Then it says, name the intersection of planes T and N. This intersection right here is what's making all these other things have like more than one answer, because when 2 planes intersect, that means their intersection is in both planes. So name the intersection. Remember that this is just a drawing, and we cannot actually draw a plane that goes on for forever, otherwise we would never stop drawing it. So it is implied that this plane extends for forever. So when they intersect, it's going to be a line, because a line also extends for forever. So we can call this a number of things, but I'm just going to call it line BC. All right. These 3-dimensional drawings with all the dotted lines and everything, it might take some getting used to, because when we work in 3 dimensions, these images can become a little tricky for us to get used to. In example 2, it says draw and label each of the following. So we want a segment with endpoints M and N. So remember, a segment is only part of a line, and it can look any number of ways. It doesn't have to look exactly like mine, but this would be an example. You might have decided to draw it just straight across or really long. I mean, it doesn't tell us much, so both of these would be examples of that. Opposite rays with a common endpoint E. Okay, well, here's my point E, and if they're opposite rays, they're going to form a line, and they have to go in opposite directions. I'm going to go ahead, my pen will work. I'm going to go ahead and put some points on the rays as well. It's not required, but it can kind of help us name more things in this if we needed to. Then it says sketch 2 lines intersecting in exactly 1 point. If 2 lines intersect, there's really only 2 options. Either they're going to have every point in common or only 1 point. So it's kind of difficult to draw 2 lines that don't intersect in only 1 point. But this would be an example of that. And let's go ahead and name that intersection P. All right. So for the very last example, once again, we're still just practicing with our terminology and our symbols and making sure that we recognize what everything is. So it says, name the intersection of planes HEF and ABC. Okay, plane HEF. HEF. Those three fall at the corner of the top of this box. So it's the very top section. Then we have ABF. ABF is the front of the box, okay? So that's the best way I can describe it. The front of the box and the top of the box. Name the intersection. So the intersection of these guys, I'll do this one in pink for you. So A is going to be in pink. They are intersecting on that line right there, okay? So that is line. Remember, line, not segment, because even though the image doesn't look like it goes on for forever, technically it does because these are planes, and planes never stop. So we have line EF. Or FE, whatever order you put it in. Then it says, list a pair of planes that will never intersect. All right, you have a lot of options with this. So for example, this front plane will never intersect with this back plane. They're basically just going to be like side by side each other, going up and down, but never moving or something like that, because planes don't curve. Or you can do the top and the bottom. That's an option as well. So I will do the left plane and the right plane. So plane EHD and plane. So this left side will never intersect with the right side, FGC. Okay. Finally, it says list two pairs of lines that will never intersect. All right, tons of options here. Not to mention, they don't have to go in the same direction. So let's start with this front line, line EF. So EF is parallel to AB, meaning they are never going to touch and they're both going in the same direction. So that would be a pair of lines that never touch. But we need two pairs. So another example, what if we did AE right here on the left side of the box? Line AE. Now, is an answer FB? Absolutely, yes it is. But you could also say line HG. And I'm using that example because I want you to see that we're working in 3 dimensions here. So EA or AE, whatever, is in front of HG. So they might not both be going up, but it's still impossible for them to intersect because they're going in 2 opposite directions. And there are lots and lots of other choices that you could have done as well. I'll do one more for you. GC, line GC, and line EA. 2 corners. All right. I hope the labeling is making sense for you, especially when you do your homework. It gets kind of picky, so make sure you're paying attention to those details. And if you have questions, I'll be sure to answer them tomorrow in class.